Now let's look at a different magnitude of out-of-control condition. Let's look at a 7.5% shift up. This is a 3 CV shift up, which is really easy to see here. As we would expect, we have a greater number of results failing to meet the quality requirement. In this particular case, 3 unacceptable results were produced since the last acceptable QC event. With this large of a shift, we expect an increased likelihood that we'll detect the shift. It only took us 1 QC event to detect it. Would we expect to get the exact same performance if we did this again? Let's do it 100 times. We find that over 80% of the time, we wouldn't expect any QC results to be unacceptable prior to the last good QC event. This is due to the fact that in over 80% of the cases, we're detecting the out-of-control condition at the next scheduled QC after the out-of-control condition occurs. There are none that are prior. We see that the number of unacceptable results since the last good QC event can now be much larger. 0 in some cases, but as large as 10 in others. That's because the probability of an unacceptable result is greater with a 7.5% shift. If we look at the expectations for each of these things, the enough is 0.7, the enough is 4.5, so the total is 5.2. This is a larger number than we had before. The expected number of QC events to detect this out-of-control condition is only 1.2, so most of the time it would be detected on the first try. However, the percent of results that are incorrect when this out-of-control condition occurred is close to 16%. To understand the other end of the spectrum, let's look at a really small out-of-control condition. What if we had a 2.5% shift upward? This is a 1 CV shift up. The out-of-control condition occurs. We see that the points are shifted up and scattering around positive 1s, but that isn't a very large shift. Therefore, we don't see any results that fail to meet the quality goal. Let's continue to quickly run more tests. So far, we've had 336 patient results that have been affected by this 1 CV shift, but none of them have failed the 10% criteria. Note that we're on the 7th QC event and have not yet detected the out-of-control condition. We're now on the 14th try, and we finally see a result that has failed the quality requirement. However, we still have not detected the out-of-control condition. Finally, on the 21st QC event, we get a rule rejection. Over 1,000 patient results were affected by this 2.5% shift, but only one of them failed to meet the 10% quality requirement. If we were to simulate this out-of-control situation again, would we expect that it would take 21 tries? No. Let's test this. Let's simulate this condition 100 times. In this case, notice that the expected number of QC events to detect this 2.5% shift is quite large, over 15. But the total E-new is only 1. The reason is that we only expect 1 out of 1,000 results to fail to meet the quality requirement when a 2.5% shift occurs. So, we've looked at 3 different cases that are shown here. This is the average number of QC events to detect the out-of-control condition. This is the percent of the results that were unreliable during the existence of the out-of-control condition. This is the expected number of incorrect results that were produced prior to the last good QC event. This is the expected number of unacceptable results that were produced since the last good QC event. The circles show the expectations that we observed in each of those cases. If we wanted, we could continue to simulate different out-of-control conditions, starting at a negative 20% shift and going up to a positive 20% shift, in small steps of 0.1%. These circles would eventually create curves. Doing this many simulations would take a lot of time. Fortunately, we do not have to do that because we've developed the mathematical algorithms that can compute these expectations without simulation. We see that the mathematical algorithms compute values that fit the 3 cases that we actually looked at, and fit all those in between. These 4 figures that are produced are included on the summary page of our risk calculator. Visit www.qcnet.com for all of your QC needs.